All right, guys, let's knock out this review 28. I can't believe we're on 28 already, but we are. We're here. Let's go. Before we take this limit, let's see if we can simplify any of this fraction. So on the numerator, I can do x plus 3x minus 2 over x minus 2. That's awesome. Those cancel. So I'm actually going to do the limit as x approaches 2 of x plus 3. And because it's addition, I can separate that and go the limit as x approaches 2 of x plus the limit as x approaches 2 of 3. I can plug the 2 in for the x. If you have a constant, it's just a constant. Limit is 5. Number 2, same type problem. Let's go ahead and work out that top limit, because the way it stands right now, I cannot plug the 0 in because h on the bottom gives me 0 in the denominator. So I'm going to cube that. So I'm going to say 2 cubed. Remember, I'm actually doing this. I'm doing a binomial theorem. So I'm all those patterns we did, 2 cubed plus 3. I'm going 1, 3, 3, 1 for my coefficient. So I'm going 1, 3, 2 squared, h, 3, 2, h squared, and then h cubed. So that's about right here. So I got 8. That's going to be 2 squared, 12h, and then 6h squared plus h cubed minus 8. And again, those first 4 terms came from cubing this thing over h. Now what happens is my 8's cancel, obviously. So I have this situation. I have, on the numerator, I got those 3 terms. So I can factor an h out of those, which gives me a 12, a 6h, and an h squared all over h. Obviously now the h's cancel. So I have the limit as h approaches 0 of 12 plus the limit as h approaches 0 of h. I should put a 6 in the front of that. Plus limit as h approaches 0 of h squared. Now I can substitute, or this is the constant, so I'll bring down to 12. I have 6 times 0 plus 0 squared. All that's just going to be 12. So there's your limit. All right, and 3 is going to get a little crazy here. Okay, so what I'm going to try to do is simplify. I can't, obviously I'm not going to plug the 7 in right there because it's going to be 0 in my denominator. So I'm going to multiply by the conjugate of the numerator, which is going to help us. So on my numerator, when I multiply by the conjugate, equal sign there. I'm doing full, right? So I get, if I do x plus 2, square root of x plus 2 squared, I just get x plus 2. And if I do negative 3 times positive 3, that's just minus 9. On my denominator, I'm not going to actually multiply this out yet. I'm going to leave it looking like this. And we're going to go from there. Okay, so what I'm seeing is my numerator is really x minus 7, which is very convenient because my denominator also has that x plus 7 in it. Kind of got lucky there, so that cancels, which gives me the limit of, as x approaches 7, of 1 over square root of x plus 2 plus 3. And here we go again. Going to break all that down. I'm going to say my numerator, the limit as x approaches 7 of 1, which is just 1 by the way. My denominator, limit as x approaches 7 of the square root of x plus 2, and then the limit as x approaches 7 of 3. So my numerator is just 1. My denominator, I can plug 7 in there. Square root of 9 is 3, plus another 3, end up with 1/6. That's all you got to do there. Number 4, absolute value. With absolute value, you have to approach from both sides, because absolute value, we're not sure. So we have to go limit as x approaches negative 4. The absolute value of x plus 4 is negative x plus 4. And also the absolute value of x plus 4 is positive x plus 4. Because the absolute value, we don't know if x plus 4 is positive or negative, so you got to take both cases there. So if I plug negative 4 in here, I'm going to get 0. All right, if I put negative 4 in here, I'm going to get 0. So because both of them are 0, the limit is just 0. No big deal there. Now 5, something else may happen here. So let's check out what happens on 5 on the absolute value. Start the same way. The absolute value of x minus 2 is either the opposite of x minus 2 or the absolute value of x minus 2 is exactly x minus 2. Again, if it's negative, it's this. If it's positive, it's this. We don't know, so you got to do both cases. All right, so that right there, that limit, that's really a negative 1. So that limit is negative 1. That's really positive 1. And because the two limits are different, obviously they're approaching two different numbers, the limit does not exist. Number 6, okay, now we got piecewise. And piecewise works very similar to the one we just did. So I'm going to say, okay, as we're going to approach 2. So if I'm approaching 2 from the left, that's the first function. So I'm going to do the limit as x approaches 2 of x minus 1, because I'm approaching that from the left side, obviously. So if I approach that from the left, I can just substitute the 2 in there. 2 minus 1, that's 1. Then I'm going to do the same thing, except I got to do x minus 2, x approaches 2 from the right-hand side. I'm going to substitute 2 into x squared minus 4x plus 6, which will give me 2 squared minus 4 times 2 plus 6, which will give me 4 minus 8 plus 6, which is 2. And because they approach two different numbers, that limit also does not exist. All right, number 7 says find an equation of the tangent line to the hyperbola y equals x over x minus 1 at the point 2, 2. So I'm going to find the slope of the tangent line first. So I'm going to follow this formula. The limit as h approaches 0 of f of a plus h minus f of a over h. And remember, the a here is our x coordinate. So I'm going to say the limit as h approaches 0 of 2 plus h, parentheses too small, sorry about that, 2 plus h over 2 plus h minus 1 minus f of 2, which if I plug in 2 right there, I'm going to get 2 over 1. All that's over h. Now I have to solve, I have to work all that out. So I'm going to multiply the top and bottom by the LCD, which is 2 plus h minus 1 over 2 plus h minus 1, which gives me the limit as h approaches 0 of 2 plus h minus 2 times 2 plus h minus 1 all over h times 2 plus h minus 1. That's a plus h minus 1 on the bottom. All right, my numerator then becomes 2 plus h minus 4 minus 2h plus 2 all over h over 2 plus h minus 1. This might take you a little room. The limit as h approaches 0 of my numerator now, 2 plus 2 is 4, that's gone. That gives me a negative h on the top, a 1h on the bottom over 2 plus h plus 1. Those h's are going to cancel. It gives me negative 1 over 2 plus h plus 1. It just hit me. I've been saying plus 1 in my denominator. It should be minus 1. I don't know why I changed that. Sorry about that. It's live TV here. Minus 1, which gives me negative 1 over basically 1 plus h. So if I put 0 in there, it just gives me negative 1. So there's the slope of my tangent line. And now I'm just going to do point slope form with the point originally to get my equation of the tangent line. So I'm going to have y minus 2 equals negative 1 times x minus 2. Let's distribute that negative 1x plus 2. Move the 2 over. Looks like I'm getting negative x plus 4. There's the slope of there's the equation of the tangent line to the hyperbola at that point. All you got to do on that one. Wow. Okay, you might want to stop this. I'm going to erase that so I have room for the next one, because this can be just like the one we just did. So I'm going to erase this bottom part so we have room. All right, number 8, same thing. Find an equation of the tangent line to that curve, y equals x plus x squared at the point negative 1, 0. So same process. All right, here we go. Got to find the slope first. And the slope is the limit as h approaches 0 of f of negative 1 plus h. I'm going to put that in. So I'm doing f of negative 1 plus h minus f of negative 1 over h. That's what I'm going to work out. So first thing I got to do is I got to plug in that negative 1 plus h. If I plug in negative 1 plus h, it's going to look like this right here. Negative 1 plus h will be negative 1 plus h. That's an h. I'm having a hard time with my h's today. Plus negative 1 plus h squared. And all that is, I'll plug that into the curve. Minus f of negative 1. If I plug negative 1 in there, I'm going to get negative 1 plus negative 1 squared, which, to be honest with you, that's just 0 all over h. So, got to work out that numerator, which is going to give me -1 plus h. Now I'm going to go square, multiply, double square, square, multiply together, double, square, all over h. Those ones are canceling, which they always will. So the limit as h approaches 0 of h squared minus h in my numerator, for the h in my denominator. Obviously, you can cancel out those h's, which is going to give me just an h minus 1 up top. Plug in the 0. My limit is going to be -1. That's the slope of the tangent line. Now I'm going to do point slope form with the -1. So I'm going to y minus 0 is -1, x plus 1. So my tangent line is just -x minus 1. There's my tangent line to the curve at that point. That was awesome. Number 9, review stuff now. 8,000 invested in an account compounding continuously. Find the amount of investment after 12 years. Okay, that's because it says continuously. That's PERT, P-E to the RT power. So I'm going to say 8,000 ER is 0.07 times 12. Just got to punch that straight in. And when I do that, it looks like I'm getting about $18,530.94. All right, number 10. Find a polynomial of degree 4 that has these. Now, if -2 has the root, remember, 2 has also a 0. So it's going to be a doozy. So I have x plus 4, bottom is factors, x minus 4. I also have x plus 2i, x minus 2. And I thought it was going to be worse than it was. Those are both conjugates. These two are conjugates, those first two. So I'm going to do foo, getting x squared minus 16. Second two are conjugates. I can do x squared minus 4i squared. Do foo again. Now, x squared minus 4i squared is really the same thing as x squared plus 4. Now I can just do FOIL, and if I do FOIL, I get x to the 4th. I'm going to do outer inner in my head. That's -12x squared. And then if I do last, I get -64. So that's what you should end up on number 10. I got to erase that real quick. Number 11, last one, finally. Graph that. State the domain, range, and asymptote. Okay, so I'm going to do a rough sketch here. I got a -2 inside the parentheses, which means it's just a graph right 2. The log, when you graph a log, the asymptote's usually on the y-axis. It's been shifted right 2. It's been shifted to right there. First point's always 1 to the right, which is the same case here. To find the second point, which is what you need, we need to make the parentheses the same as the base, which means I'm going to plug in 5 for x because 5 minus 2 is 3. So if I have log 3, that's 1. How did I get the 3? I plugged in 5. So my point is 5, 1, which is right there. And I connect the dots. Then you got to tell your domain to range and stuff. Your domain is just going from the right of the asymptote, so it's going to be from 2 to infinity. Your range is going up and down forever. It's all reals. And your asymptote, because it's vertical, is x equals 2. All right. Guys, I got to apologize. That video, as far as it didn't feel like it was the greatest. I hope it helps. It needs to. So I only got 3 more tests after this. Hang in there. Come see me tomorrow if you need to. We'll get it worked out for you. All right. Have a good one.